In this video, I'm going to use an Arduino to read and write data to an external EEPROM chip. And EEPROM stands for Electrically Erasable Programmable Read-Only Memory. And this is a type of non-volatile memory. So what that means is that it will retain data even after you power cycle the chip. You can remove power from the chip, and when you turn the power back on, the data is still going to be there. And the Atmega 328 chip found on the Arduino Uno actually has 1 kilobyte of internal EEPROM, but EEPROM has a limited number of writes, and it's you can get larger storage on external chips, so that might be some reasons to use an external EEPROM. And so you could use it to store maybe configuration data or statistical data for sensor measurements and things like that. Okay, so the chip I'm going to use is called the 24LC 512 EEPROM chip, and this model stores 64 kilobytes of data, and each byte is individually readable and writable. So the word size is basically just 1 byte. According to the data sheet, there's a limited number of writes you can make to each address, and it's 1 million. And so this is going to be the pin layout. You can see the little dimple here at the top. So this is pin 1, 2, 3, 4, 5, 6, 7, 8. And pins 1, 2, and 3 are address pins. This is an I2C serial protocol chip. So you can set each I2C address for each chip. If all three of these go to ground, the address is going to be 50 hex. But since there's 3 lines, you can adjust these and actually get 8 different addresses. So you can get 2 to the third power, so that's 8. And so you could have 8 chips on the same I2C bus, addressable by the Arduino. So pin number 4 is just the ground pin, and then pin number 5 is the I2C data pin. So that's going to go to the Arduino A4 analog 4 pin. Pin 6 is the I2C clock pin, and that's going to go to the Arduino analog A5 pin. Pin 7 is the write protect. So you could write to this chip, and if you wanted to make sure the contents don't get overwritten, you would set pin 7 to high, and that means you cannot write to this chip anymore. You could write to it again if you make that pin low, but if that pin is high, it's write protected. So I have it low since we're going to write to it. And then, of course, pin 8 is the VCC pin, and this runs on 5 volts. So you just set that to the 5-volt power rail. You'd be powered by the Arduino. Okay, so this is the Arduino sketch that I'm going to use, and so first off, I'm going to include the wire.h library, and that's to allow you to use the I2C protocol. Then I'm going to define the EEPROM I2C address, and recall, since I have all 3 address pins set to 0, that's going to make the address 50 hex, and you can get that from the data sheet. Okay, so then in the setup, I'm just going to do wire begin, so that kind of initializes the I2C buses, and then I'm going to do serial begin because I'm going to write some of this information to the serial monitor just to verify that it's working. So what the sketch is going to do, it's going to just, at address 0, it's going to write a value, a byte value. So I'm setting these variables here, setting the address to 0, the byte value to 110, just pick randomly. Then I'm going to call a method called write address, and I'm going to pass it that address and the value. And then I'm going to call read address and pass it the address, and that's going to return the byte value back from that address. And then I'm going to print it out just to show that it really did write and read to that address. So this is all done in the setup, just a one-time thing, so there's nothing going on in the loop. So yeah, and the write address again passes in the address and the value. This is the in I2C. That's how you begin a write transmission. And then for this chip. The address is 2 bytes long, so there's a most significant byte and a least significant byte. So you have to actually do 2 writes. Okay, so I'm writing to address 0, so this address, both of these writes are going to be 0, and then I'm going to write in the value and then do end transmission, and then I'm going to have to do this delay 5 milliseconds, because if you look at the data sheet, it takes a maximum of 5 milliseconds to write a value. So if you don't have this in here, I notice, and you try to read, you're not going to get the value back. So you have to wait 5 milliseconds after you do it right. If you're doing like I did, if you're reading right after you do it right, you're going to have to put that delay in there. Okay, so then read address, pass it the address. Again, you do begin transmission, and you have to write the address you're going to read from. So this little section of code is similar to the write function, although you're not going to actually write anything to it, but you do have to set the address pointer in the same way. And then you do end transmission. So then you do wire request from, you pass it the I2C address and how many bytes you want to read. So I'm reading 1 byte, so I'm going to do wire.read, that returns our data, so I return that back and then print that out. So if let's say plug the Arduino in, which we're pointing to, I'll upload the sketch. Okay, and then we'll look at serial monitor. Okay, so you can see the return value is 110. Of course, that's what we expected. So this is where that's printing that out. So after it does the read and the write, just to verify that it works. So anyway, that's basically how you would use an external EEPROM chip. There's a lot of storage space there. They're not really meant to be written to a lot, although datasheet says 1 million writes, but you should keep that in mind. So I don't know, you could maybe have some kind of algorithm in there if you're, if you were storing data, maybe switch these addresses, kind of rotate them up so it doesn't always write to the same address every time and wear it out. I don't know if that's really necessary or not. Also, the datasheet says the values are good for like 40 years, so if you write to that chip once, supposedly they'll still be there 40 years from now. So, well, there it is. Hope you enjoyed the video.